Problem 106, chapter 5. This is a very good problem. So here we have this mechanism. We have two bars. OB is pinned to the ground at point O, and it is rotating with constant angular velocity of alpha. So angular acceleration of it is 0. AB is pinned to the first link from the other side at point A. It has a roller which is moving just in the vertical direction. So at this moment, when OB is in the vertical direction, the question is, what is the angular acceleration of AB? What is the angular acceleration of this link? This is a very good problem. You need to think about it for sure before seeing me how to solve it. So I would ask you to stop this video, pause it, and think about it at least for 15 minutes, then come back to this video. So I assume you did that. Let's see what we have here. We have this bar which is rotating with angular velocity of omega, which is constant, so alpha of it is 0. And we are trying to find the angular acceleration of AB. So in the equations where we have that angular acceleration, if I write the relative acceleration between A and B, then you're going to see alpha of this link is going to show up in that equation. So probably I need to use that equation, right? But if you do that, which I'm going to do this later, you're going to see you have more than two unknowns in that equation. That's going to be the relative acceleration equation between A and B is a vector equation, which means it is two equations, two independent equations in the I and J direction. But if you write down the equation, you're going to see you have three unknowns. And one of them is going to be omega of this link, omega of AB. And we need to find that before finding alpha. What I mean, I'm going to explain it later a little bit more after writing that equation. But for now, just trust me, we need to find omega of AB first before finding the alpha of it. We can't find the alpha unless we find this omega, okay? So my first goal is finding the angular velocity of this link, which you had similar problems in the previous chapter. There are different ways to find omega of AB. For example, we can write the relative velocity equation between A and B, which I'm going to do it here. Or you can use the instantaneous center of rotation of this link. You can find the instantaneous center quite easily, which I explain it later. Let's go with the first method. If I write the relative velocity equation between A and B, then omega of this link is going to show up in that equation. So let's do that. Velocity of A is equal to velocity of B plus velocity of A with respect to B, which is equal to omega of this link, omega of AB, cross product to BA. You can write it the other way too. You can write velocity of B is equal to velocity of A plus omega cross AB, right? It is exactly the same thing. So how we can find omega of AB from this equation? We can do that because we have only two unknowns here. Velocity of A is unknown, but we know the direction of it. A is moving on this slot, so it's gonna move just in the J direction, right? So this is my coordinate, X and Y. Velocity of A is something, velocity of A, but the direction of it must be in the J direction. So I have only one unknown here so far. Is equal to velocity of B. We know the velocity of B because B is a point on this link too, and this link is rotating with angular velocity of omega about O. So the velocity of it is going to be R times omega, and it's going to go to the left. Velocity of B is equal to OB, which is r times omega. And omega is given. So velocity of B in the vector form is gonna is gonna be negative r times omega in the I direction, plus omega of AB is unknown, but I'm gonna assume it is in the K direction. Actually, it is in the K direction. It can be positive or negative, right? Whenever you have a rigid body which is rotating in a plane, always it's gonna be in the K direction, the angular velocity of it. It can be positive or negative. So omega AB is omega AB times K hat. So omega AB is unknown here too. Cross product to BA, this vector. So we need to write down this vector. And this vector is simply r in the I direction, negative r in the J direction. So it's gonna be r I hat, negative r J hat. So let's do this cross product. K cross I is J, so I'm gonna have r omega AB in the J direction. K cross J is negative I. We have another negative here. So plus r times omega AB times I hat. Now here we have a vector equation, right? And we have two unknowns here, velocity of A and omega AB. So if I split this equation to I and J terms, I should be able to find both of them. So for I have nothing here on the left side of the equation. On the right side of the equation, I have negative r times omega in the I direction, and also I have positive r times omega AB in the I direction. And for the J direction, velocity of A here, and in the other side of the equation, we have r times omega AB. From the first equation, we are going to be able to find omega AB, which is going to be equal to omega. Okay? From the second part of the equation, we should be able to find velocity of A. So velocity of A is going to be r times omega AB, which is equal to omega. So simply r times omega, but we don't really need it for now. So after finding angular velocity of this link, now we can find the angular acceleration of it. How? By writing the relative acceleration equation between A and B. So let me write the equation, then I can explain it more after that. Acceleration of A is equal to, A and B are on the same rigid body, so I can use the equation that we studied today. Acceleration of A is equal to acceleration of B plus alpha of this rigid body, alpha of AB, cross product to BA, and plus omega cross BA, or negative omega squared times BA, and omega of AB. Okay, because these 2 points are on the same rigid body, we should be able to use this equation. Now look at this equation, and let's count how many unknowns we have here. Acceleration of A, we don't know the magnitude of it, but we know it must be just in the J direction because A is moving just in the J direction. So we have one unknown here. Acceleration of B. Do we know acceleration of this point, B? Yes, we do, because B is a point on this rigid body too, and we know this rigid body is rotating about O with angular velocity of omega and 0 acceleration. So we have all the information about point B. Velocity of it is going to be r omega squared, and because it's a point which is moving on a circle about point O, acceleration has two components, if you remember. The tangential part of it is going to be r times alpha of this link, OB, which is 0. So the tangential part of acceleration of b is 0. But we are gonna have normal acceleration too with the magnitude of r times omega squared. So acceleration of b at this moment is gonna be just in the j direction, downward in the negative j direction, with the magnitude of r times omega squared. So we know everything about this vector. Now here, alpha AB, it's unknown, but we know it's gonna be in the k direction or negative k direction. So we have one unknown here, the magnitude of this vector, alpha AB. BA, we know what is this vector. Omega AB, we found it in the previous part, right? And because we found it, it's not unknown anymore. So at the moment, we have only two unknowns here, acceleration of A and also alpha AB. So we should be able to use this equation to find alpha AB and also acceleration of A. If we didn't do this part, if we didn't analyze the velocity, and if we didn't know omega AB, then here we could have had three unknowns: acceleration of A, alpha AB, and omega AB. But this is a vector equation. We have only two equations here, so we shouldn't be able to find alpha. That's the reason we did this velocity analysis to find omega. Because after that, then this is not going to be unknown anymore. So here we are going to have only two unknowns, and also it is two equations. So mathematically, we should be able to find both unknowns. Okay, so let's put, excuse me, let's put all the information here. Acceleration of A is acceleration of A times j hat is equal to acceleration of B, we talked about it, is going to be negative r omega squared in the j direction. Alpha AB, we know it is in the k direction. It could be negative 2 cross BA, which is r in the I direction, negative r times j, minus omega AB squared, and we know what is omega AB, it is equal to omega, so I'm gonna have omega squared times BA, again r I hat minus r times j hat. Okay, we have a cross product here. So k cross I is j, so r alpha AB times j hat. K cross j is negative I, and then negative here, so positive r times alpha AB I hat. Now, if I separate I and j terms, then I can construct my equations and find the unknowns. So for I have nothing in the left side of the equation, so 0. On the right side of the equation, I have this part, r times alpha AB. And also I have this part, negative r times omega squared. For j parts, I have acceleration of A in the other side of the equation. In this side of the equation, I have negative r omega squared. Then I have r times alpha AB. And here I have r times omega squared again, but positive here. So these two are going to cancel out each other. From the first equation, we can find alpha, which we were looking for. Alpha AB is going to be equal to omega squared. So we are done with this problem. We found alpha of that link. But if you want to find acceleration of A, which is not in the problem, is equal to r times alpha AB, which is equal to omega squared. So it's going to be r times omega squared.